Dear students, we are going to study electronic devices, and in this we will be studying a PN junction diode and its working in forward and reverse bias, and also its use as half wave and full wave rectifier. Now first let's start with formation of PN junction diode. Now when a p-type semiconductor is joined to n-type semiconductor such that the crystal structure remains continuous at the boundary, then this arrangement is called PN junction diode or a semiconductor diode or a crystal diode. Now here you can see that we have a p-type crystal where holes are majority charge carriers and they are attached with negative ions, negative acceptor ions, and n-type has electrons as majority charge carriers and they are attached with positive acceptor, positive donor ions. Here for the sake of simplicity, the minority charge carriers are not shown. Now let's see what happens when the junction is formed. Now holes from p side and electrons from n side try to diffuse through the PN junction due to the difference in concentration level or due to concentration gradient. So electron hole recombination take place at the junction. As a result, a layer of immobile positive and negative ions are formed across this PN junction. So this layer is called depletion layer, and in depletion layer there are no free charge carriers. Now the n side has positive ions and p side has negative ions. So an electric field is set up from n side to p side. This electric field opposes the further flow of electrons from n side to p side, and it also opposes the flow of holes from p side to n side. So due to this electric field, a potential difference is set up at the junction, with n side being positive and p side being negative. This potential difference is called potential barrier. You can see. Now this electric field supports the flow of minority charge carriers, but majority charge carriers are stopped by this electric field or this potential barrier. Now the current due to flow of majority charge carriers is called diffusion current. Diffusion, because it is happening due to diffusion, so diffusion current. And current due to flow of minority charge carriers is called drift current. Drift. The potential barrier is also called height of barrier. For example, for silicon, the potential barrier is about 0.7 volt, and for germanium it is 0.3 volt. Now the use of PN junction diode is of two types. One is in forward bias and the other one is in reverse bias. So in forward bias, the p side is connected to positive terminal of battery and n side is connected to negative terminal of battery. Now the positive terminal pushes the holes towards the junction and negative terminal pushes the electrons towards the p-n junction. So as a result, the thickness of depletion layer decreases and majority charge carriers rush towards the junction and electron hole recombinations take place at the junction. So due to flow of electron majority charge carriers, a large current of the order of milliampere flows through the circuit. You can see. Now, once the electrons from n side reach the junction and holes from p side reach the junction, more electrons enter from the battery towards the n side to compensate for the used electrons. Similarly, in p side, covalent bonds are broken to give holes and electrons, and the electrons leave this terminal to reach the battery and holes move towards the junction. So as a result, a completion of circuit takes place and continuous current flows through it. Now, the use of this diode in reverse bias. Now here, the P side is connected to negative terminal of battery and N side is connected to positive terminal of battery. So what happens? That this negative terminal pulls the holes towards it and positive terminal pulls the electrons towards it. So majority charge carriers, electrons and holes are pulled away from the junction, and as a result, the thickness of depletion layer increases. And very few minority charge carriers can pass through the junction. So a negligible current of the order of microampere can only flow due to flow of minority charge carriers. But you can see the thickness of depletion layer. Now once the external reverse bias increases to large extent, then some of the electrons are pulled out from the covalent bond and they have high kinetic energy, so they knock out more and more electrons from the covalent bonds, and as a result, suddenly large number of charge carriers are available and current in the circuit rises suddenly. This situation is called reverse breakdown. Now the PN junction diode conducts large current in forward bias and almost negligible current in reverse bias. So it is a unidirectional current device. Now, diode characteristics. So in forward bias, so you see the circuit. The P side is connected to positive terminal of battery. See, this triangle side is P side and this line is N side. This is symbol of a diode. A milliampere is connected to it, milliammeter, and you see the current rises sharply of the order of milliampere. The forward bias at which the current starts to rise sharply is called knee voltage. Now in reverse bias, see the P side is connected to negative terminal of battery and N to positive, and initially the current is almost negligible and then breakdown occurs and current rises sharply. Now resistance of diode. It has two types of resistances. One is called static or DC resistance it is equal to the ratio of V upon I, and dynamic or AC resistance, it is equal to delta V upon delta I, or change in voltage upon change in current. Now, PN junction as a half wave rectifier. Now, as I have already told you that this diode is a unidirectional current device. So, the flow of current is only in the forward bias and there is no flow of current in the reverse bias. So, when an AC input is given to this diode, it conducts for one half only and output is in one direction. That is, it has been converted to DC. So, when the positive half is given as input, you can see, and this is transformer. So, due to mutual induction, the signals are given to the diode. So, when the diode is forward biased, a current passes through the circuit and an output is obtained across the load resistance RL. But when the diode is reverse biased, the diode there is no current passing through the diode, it does not conduct, so no output is obtained. Now this is the combined circuit diagram here. This is input, this is AC input VI and the output VO. So for the positive half, when diode is forward biased, output is obtained, and when it is reverse biased, output is not obtained. So only half of the wave is obtained across the output, and so it is called half wave rectifier. Now let's talk about PN junction diode as a full wave rectifier. So here we use two diodes in parallel and a center tapping is used. This is center tapping. So when D1 is forward bias, D2 will be reverse bias and vice versa. Now you can see the positive and negative side. Now when the positive input is given, D1 is forward biased and output is obtained across this load. The current passes from B to A, but in this situation D2 is reverse biased, so no current passes through it. Now for the negative half, D1 is reverse biased, so no current passes through it, but D2 is forward biased, so current passes through it, and the direction of current is same, that is from point B to point A, and output is obtained. Now combining the two diagrams, yes, you can see that an output is obtained across load RL along the same direction from B to A. That means we can say that this AC input has been converted to DC. This is your input voltage VI and this is an output voltage VO. So that's how the AC has been converted to DC, and full wave has been converted, so it is full wave rectifier. It's working, you can see. Thank you.